Good morning. This is the third introductory lecture on the chapter Electrostatics, and today we are going to study an article, Position of Third Charge in Equilibrium. This article is important from the entrance examinations point of view. So no one asks you this article in theory examination. Okay. So have to find the position of the third charge which should be in equilibrium. So let us first study what is mean by an equilibrium. Okay. So when the total force which is acting on a charge, if it is equal to 0, or the total electric field intensity, net electric field intensity at the given point, if it is equal to 0, then we can say that the charge will be in equilibrium. Okay. So the question is like this. The two like charges are given, plus q and plus 4q, which are separated by a distance capital L. Then where should we place the third charge, which is the plus capital Q, so that this charge would be in equilibrium condition? Okay. So in order to solve such a kind of questions, first of all, let us consider or let us study if the charge is placed here, somewhere here in between these two like charges, then the total force or the net force acting on the charge plus Q, or the net electric field which is produced at the charge Q, is equal to 0. Okay. But when the charges are unlike charges, means one of the charge is positive and another one is negative, then in that case we can't place the third charge in between these two charges. The charge should be placed outside the two charges. Okay. जर दोन लाईक चार्जेस असतील, प्लस प्लस और मायनस मायनस, तर तिसरा चार्ज हा दोघांच्या मध्ये प्लेस केला तर आणि तरच तुम्हाला रिझल्टंट इलेक्ट्रिक फील्ड ही 0 मिळणार आहे, किंवा रिझल्टंट नेट फोर्स या चार्जवरचा 0 मिळणार आहे. जर तो चार्ज तुम्ही कुठे आउटसाइड प्लेस केला तर तुम्हाला रिझल्टंट फोर्स और रिझल्टंट इलेक्ट्रिक फील्ड 0 मिळणार नाही. पण जर अनलाइक चार्जेस असतील तर थर्ड चार्ज हा दोघांच्या मध्ये प्लेस न करता तो बाहेरच्या बाजूला प्लेस करायचा आहे. अँड अगेन अन इम्पॉर्टंट पॉइंट इज दॅट इफ द टू चार्जेस आर लाइक चार्जेस, then the third charge should be kept nearer to the smaller charge. Okay. Here also nearer to the smaller charge. We can't place the charge here. जो लहान चार्ज आहे, ज्याचं मॅग्निट्यूड लहान आहे, त्या चार्जच्या जवळ तुम्हाला तो तिसरा चार्ज प्लेस करायचा आहे. ओके. While solving such a kind of numericals, don't consider the polarities of the charges while putting the values in the formula. फक्त त्यांचं मॅग्निट्यूड तुम्हाला कन्सिडर करायचं आहे. सो दोन इम्पॉर्टंट कंडिशन्स आहेत. लाईक चार्जेस असतील तर थर्ड चार्ज त्यांच्यामध्ये प्लेस करायचा आणि जो स्मॉलर चार्ज आहे त्याच्या जवळ प्लेस करायचा. त्या पॉइंटला तुम्हाला नेट फोर्स आणि नेट इलेक्ट्रिक फील्ड 0 मिळेल. And if the two charges are unlike charges, then we have to place the third charge outside the two charges and closer to the smaller charge. Then we'll get the electric field or net electric force at this point equals to 0. And we can say that the third charge is in equilibrium. Okay. So have to find this distance. Okay. So suppose this distance between the two charges, if it is capital L, then assume the third charge is placed somewhere here at a distance x from the smaller charge. So obviously the rest of the distance is L minus X. Actually, for this there is a standard derivation, but derivation is not important for the examinations, theory or entrance examinations. So just memorize this formula. X equals to under root Q1 upon under root Q2 plus under root Q1 into capital L. Capital L is nothing but the distance between the two charges. Okay. Q1 is nothing but the smaller charge and Q2 is nothing but the larger charge. Okay. So X equals to, substitute the values. Here Q1 is nothing but the Q. So here root Q. Here Q2 is nothing but the 4Q. So here 4Q. Plus again Q1 is Q. So substitute the values and solve it. Under root 2Q means 2 into root Q plus root Q into L, and in the numerator there is root Q. So 2 root Q plus root Q means here 1 root Q. Okay. So 2 plus 1 equals to 3. 3 root Q. Root Q get cancelled with one another, and we'll get the X equals to L by 3. So we should kept the third charge at a distance of L by 3. Means this distance is equal to L by 3. So the third charge should be placed at a distance L by 3 from the smaller charge, and the third charge will be in between the two like charges. Okay. जर इथे मायनस Q आणि मायनस 4Q असतं तरी सुद्धा तुम्हाला चार्ज मध्येच प्लेस करावा लागला असता आणि तो स्मॉलर चार्जच्या जवळ. Now the next condition, if the two charges are unlike charges, so if the charges are unlike charges, then the third charge must be kept outside the two charges and closer to the smaller charge, and we can find this distance X by using this formula. X equals to under root Q1 upon Q2 minus under root Q1 into capital L. Okay, so these two formulas are quite similar, just the difference of minus sign here, and here there is a plus sign. Okay, so you have to by heart these two formulas. Okay, so X equals to under root Q upon under root 9Q. The first charge is Q. Okay, under root Q2 means under root 9Q. Don't consider the polarities of the charges while substituting the values. Okay, just put root 9Q minus root Q1 means Q, root Q into L. Solve it, you will get X as L by 2. So this distance is equal to L by 2. So at this distance, the third charge, capital Q, should be in equilibrium condition. Okay, so here lastly I have write those lines. If two charges are unlike charges, then third charge should be placed outside and nearer to the smaller charge to get the equilibrium condition. And a special note, do not consider the polarity of the charges. Okay, now an important article, electric field intensity. Actually, we know that electric field, okay, this electric field can be expressed in two ways, or electric field can be expressed in two ways. The first way, it can be expressed in a vector form, and in the another way, it can be expressed in the scalar form. So its vector form is E bar, electric field intensity, and its scalar form is electric potential. Don't write bar over this V because electric potential is a scalar quantity. So electric field intensity आणि इलेक्ट्रिक पोटेन्शियलच्या टर्म मध्ये आपण इलेक्ट्रिक फील्डला एक्सप्रेस करू शकतो, एक्सप्लेन करू शकतो. त्यातली पहिली क्वांटिटी आहे इलेक्ट्रिक फील्ड इंटेन्सिटी, which is represented by a symbol E bar because it is a vector quantity. And what is the definition of this electric field intensity? So suppose we have a positive point charge plus Q which is placed in air medium. and there is a point P at which the test charge plus Q0 is placed. टेस्ट चार्ज म्हणजे असा चार्ज की जो इलेक्ट्रिक फील्डला डिस्टर्ब करत नाही, ओरिजिनल इलेक्ट्रिक फील्डला डिस्टर्ब करत नाही. In the absence of this charge, we know that this plus Q produces its own electric influence, okay? And in that electric influence, we have placed another test charge plus Q0. But this plus Q0 test charge doesn't violate or disturb the original electric influence which is produced by the charge plus Q. So when we put this plus Q0 at a distance r from a charge plus Q, then obviously this charge plus Q exerts a force of repulsion, because here both the charges are positive charges. So force of repulsion on a charge plus Q0, and the direction of the force is like this. आपल्याला माहिती आहे जर चार्ज हा पॉझिटिव्ह चार्ज असेल तर त्याच्यापासून तयार जो इलेक्ट्रिक फोर्स होईल तो त्या चार्ज पासून अवे असतो, दूर काढायचा असतो. सो पॉझिटिव्ह चार्ज आहे म्हणून फोर्सची डिरेक्शन या बाजूला आहे. जर हा निगेटिव्ह चार्ज असता तर आपण फोर्सची डिरेक्शन टुवर्ड्स द चार्ज काढली असती. ओके, आता इलेक्ट्रिक फील्ड इंटेन्सिटी मीन्स काय आहे. जर हा पॉइंट पी आहे तिथे प्लस Q0 हा टेस्ट चार्ज ठेवलेला आहे. सो प्लस क्यू मुळे या पॉइंट पी च्या ठिकाणी किती इलेक्ट्रिक फील्ड तयार झालेलं आहे. ओके, सो इलेक्ट्रिक फील्ड इंटेन्सिटी इज इक्वल टू द इलेक्ट्रिक फोर्स हियर, द इलेक्ट्रिक फोर्स which is acting on the unit positive test charge. Okay, so electric field intensity is equal to electric force per unit test charge. Okay, and the direction of E bar is same as that of the direction of F bar. जिकडे इलेक्ट्रिक फोर्स हा डायरेक्शन असेल तिकडेच इलेक्ट्रिक फील्डचं सुद्धा डायरेक्शन असणार आहे. जर हा निगेटिव्ह चार्ज असता ते इलेक्ट्रिक फोर्स पण या बाजूला असतं आणि इलेक्ट्रिक फील्ड सुद्धा याच बाजूला असतं. ठीक आहे, सो SI युनिट ऑफ इलेक्ट्रिक फील्ड इज न्यूटन पर कूलोम, or it has another special unit which is volt per meter. We can consider this relation later on in the next articles. And the dimensions are, so dimensions of electric field intensity is equal to dimensions of F upon dimensions of Q0. Now we are familiar with the dimensions of force and Q0 means charge. Substitute the values or the dimensions and we'll get the dimensions of electric field intensity as M1, L1, T raised to minus 3, I raised to minus 1. Okay, so this is all about the electric field intensity. Just by heart the formula E equals to F upon Q0 in magnitude form. Okay, also E equals to dV upon dx. Here V is nothing but the potential and x is nothing but the distance. So E equals to dV upon dx. This is another formula to calculate the electric field intensity, or this is nothing but the relation between electric field intensity and the electric potential. So from this formula we'll get the unit of electric field intensity as volt per meter. Its potential, so its unit is volt, and distance, so meter, volt per meter. Okay, now electric field intensity due to a point charge. So this is a point charge and at a distance r, the value of electric field intensity equals to 1 upon 4 pi epsilon 0 Q upon R square. We have seen this derivation in the 11th standard. So if there is a point charge, then it produces electric field intensity as E equals to KQ upon R square, where K is nothing but the dielectric constant. Okay, so the charge is placed in air medium. So dielectric constant equals to 1 upon 4 pi epsilon 0. So most of the time in entrance examination we have to this formula. Use this formula. Okay, E equals to KQ upon R square. Okay. So from this we'll get the relation as E is inversely proportional to R square. Means electric field intensity obeys inverse square law of distance. R is a distance, it's a square and inverse. So inverse square law of distance. Okay. So as we go away from a charge, as this distance increases, electric field intensity gone decreasing. Means suppose if we place the charge here plus Q0, then at this point the electric field intensity will be maximum. आणि जसं आपण तो चार्ज या बाजूला नेत जाऊ, हे डिस्टन्स वाढवत जाऊ, तसं इलेक्ट्रिक फील्ड इंटेन्सिटीची व्हॅल्यू काय होणार आहे, कमी होणार आहे. ग्राफिकली जर आपल्याला दाखवायचं असेल, हे सपोज दिस इलेक्ट्रिक फील्ड इंटेन्सिटी आहे विच इज टेकन अलोंग y axis and this is the distance along x axis, then there is a exponentially decrease in the electric field intensity with respect to R. Okay. R square. So या पद्धतीचा R या पद्धतीचा हा फॉर्म्युला असणार आहे E versus R. Okay. So next, electric field intensity due to the system of charges. So इथे आपण फक्त एकच चार्ज घेतलेला होता. Now suppose if we have the system of charges, here we took the three charges plus Q1, minus Q2 and plus Q3, which are placed in air medium. So what will be the resultant electric field intensity at point O? So O च्या ठिकाणी हे तीनही चार्जेस इलेक्ट्रिक फील्ड इंटेन्सिटी कंट्रीब्यूट करणार आहे. फर्स्ट ऑफ ऑल लेट अस सी the directions of the electric field intensities. So this is a positive charge. So obviously electric field intensity acts away from it. So this is the direction of E1 bar. Okay. Now this is a negative charge. So the direction of electric field intensity is towards the charge. Okay. And for the third charge, again a positive charge. So electric field intensity is directed like this. Okay. So the net resultant electric field at point O is equal to, suppose that electric field intensity as E0 bar, net electric field, which is the sum of all the individual electric field intensities, means E1 plus E2 plus E3. So just substitute the values. E1 equals to, by using this formula, K is a constant, R is the distance. Okay, this distance R, same distance. So K Q1 upon R square plus K Q2 upon R square plus K Q3 upon R square. एक गोष्ट लक्षात घ्या, जोपर्यंत आपण इलेक्ट्रिक पोटेन्शियलचे न्यूमेरिकल सॉल्व्ह करत नाही तोपर्यंत चार्जेसची पोलॅरिटी कन्सिडर करायची नाही. जर आपण इलेक्ट्रिक फील्ड इंटेन्सिटी वेक्टर फॉर्म मध्ये लिहित असू, जर आपण इलेक्ट्रिक फील्ड इंटेन्सिटी वेक्टर फॉर्म मध्ये लिहित असू तर आणि तरच पोलॅरिटीज कन्सिडर करायच्या आहेत. मीन्स जर मी इथे इवन फक्त लिहिला, इवन त्याची व्हॅल्यू असेल K Q1 अपॉन R स्क्वेअर, बट वेन एव्हर वी राईट E1 बार और सपोज E2 बार, ओके, E2 बार K Q2 अपॉन R स्क्वेअर, but whenever we write E2 bar, then we should write K minus Q2 upon R square. So while writing the electric field intensity in vector form, write the polarity of the charge. But whenever we consider just the magnitude of a charge, E2, just magnitude, then don't write the polarity. Okay. इलेक्ट्रिक पोटेन्शियलचे न्यूमेरिकल सॉल्व्ह करताना फक्त आपल्याला पोलॅरिटीज कन्सिडर कराव्या लागतात. अदरवाइज बाकीच्या न्यूमेरिकल्स मध्ये तुम्ही पोलॅरिटीज कन्सिडर करायच्या नाही. ओके. सो एक्झाम्पल बेस्ड ऑन दिस आर्टिकल, फाइंड नेट इलेक्ट्रिक इंटेन्सिटी ॲट ए. सो EB equals to, okay, this is the equilateral triangle. Okay, so all the three angles equals to 60 degree, and these are the three vertices or the points A, B and C. So at point B and C, the charge plus Q and minus Q is situated respectively, and the side of this equilateral triangle is A. आणि त्यांनी विचारलेला आहे what will be the resultant electric field intensity at this point. Okay. So here positive charge, so electric field intensity acts away from it. So this is the direction of electric field intensity due to this charge. हा चार्ज सुद्धा याच्यावरती इलेक्ट्रिक फील्ड एक्झर्ट करणार आहे. सो हा निगेटिव्ह चार्ज आहे, त्यामुळे इलेक्ट्रिक फील्ड इंटेन्सिटीची डिरेक्शन कुठे आहे, या बाजूला आहे. ओके, सो ईबी बार आणि हा काय आहे, ईसी. सो ईबी इक्वल्स टू के क्यू अपॉन ए स्क्वेअर. Charge is Q, distance is A, so KQ upon A square, and EC equals to, EC means EC here, KQ upon A square. Polarity consider करायची नाही. आणि या दोन वेक्टर्स मधला अँगल, so if this is 180 degree, whole angle is 180 degree, so this is 60 degree, so 180 minus 60 means 120 degree. Just substitute the value and find the E net. Okay. Similarly, here also a square is given with a side A, okay, and the three charges are placed plus Q, plus Q, plus Q, okay. So, find the net electric field intensity at point C. Same example आहे जसं आपण आधीच्या फोर्सच्या याच्यामध्ये सुद्धा आपण रिझल्टंट फोर्स फाइंड आउट करताना सुद्धा सेम एक्झाम्पल पाहिलेला आहे. फक्त इथे फॉर्म्युला डिफरंट असणार आहे आणि इथे आपण इलेक्ट्रिक फील्ड इंटेन्सिटी फाइंड आउट करतोय. सो तुम्ही ते लास्ट एक्झाम्पल पाहिलं तरी सुद्धा चालेल. थँक्यू.